I think I just muted you, sorry.
It's good to know that that the chairs have the power to do that, even to each other. Right. Do I want to share my screen? Very nice, very nice. That, let's see if that sticks. No, it doesn't. Oh, good. I knew I should have done this on two devices. I'll just keep the windows right next to each other. When I'm using Linux, and apparently when you switch another virtual desktop, it stops painting the windows that aren't on the current desktop, so, which is rather annoying, but oh well.
You need to write up a draft and submit it if you want us to discuss that, Kyle.
Page fit. There we go. All right. So, you want to kick us off? Or I can do it. I can't hear you, Leslie. Unless that's me.
We'll get going for...
Oh, there we go.
All right. Can you hear me? Yes?
Yep.
No? Okay, thanks. Yeah, so we'll get going for real in a minute. We have the note well, the standard note well. Please make sure that you understand that you are at an IETF meeting, and as such, everything you say can and will be used in the course of IETF proceedings. Standard concerns about if you are aware of any IPR, you must disclose it. I will let you all read the slides and the note well. And as you are reading that, I would also like to have a volunteer or two to work on the notes in the CodeMD note-taking notepad, and of preference, somebody who can track the Jabber/chat window and carry forward any questions for people who need it. Or do we even really need that anymore?
I'm not sure we need it. I've been, in other groups we've done it, we haven't had a Jabber scribe officially, like in the old days, since everybody that was in the window was also online.
Right.
I'll be happy to I'll keep half an eye on it, Leslie.
Okay, thank you. And thanks to Jake, who has said he will lead the charge on the notes. I would certainly appreciate if others can get in the CodeMD session and help Jake out so that he's not all by his lonesome.
Jake?
Yep. Jake Holland, thanks. Okay, then I think we are good to go. Can you move to the next slide?
Do you see it?
Nope. Yep, sorry. There we go.
That's all I can think of.
Yeah, cool. So we've done the note well, and now is a moment to bash the agenda. This is the agenda as it was circulated on the list, except correctly noting that Spencer Dawkins will be doing the OpsCons update. Yes, so any bashes to the agenda, or are we good to go? Not seeing any bashes. I will take that as good to go. Again, thanks for the, yeah, you can back up to the agenda, please. We'll go to the milestones discussion at the end of the meeting. So for now, we'll dive in. First, the first thing I wanted to introduce, and I hope Francis is here. Yes, he is. Excellent. I had sent around to the mailing list a pre-watch for the excellent presentation of the work done, the excellent presentation that was shared in the IRTF open meeting, and thank you, Colin, for pointing it out to us. The Learning in Situ, a Randomized Experiment in Video Streaming by Francis Yan. And so I asked people to have a look at that, have a look at the paper, and come prepared with observations and or questions for Francis. Francis, thank you for joining us. And I would ask, great. So with that, can we have a queue for questions, please?
Spencer.
The IRTF, and then thanks the chairs for bringing it to the attention of MOPS. I wanted to thank you for this very valuable work, and I found it especially valuable because we do a lot of work comparing ABRs mechanisms using simulators and emulators, and you're reporting results from, measured results from actual measurements for work for media streaming at the on American networks at scale. One of the most interesting things you reported was that it takes about 2 years of video to get even a 20% confidence rate on differences between ABR mechanisms. Did I get that right?
Yes, it takes as much as 2 years of data per scheme to measure 20% of difference.
Fabulous. So yeah. I'm suspecting that that's the case because you don't see lots of congestion events on ISP paths in the U.S. with relatively short paths compared to the rest of, compared to the entire planet, and that you're going over pretty heavily managed network paths. It seems to me that it would be a useful thing to be running over less managed network paths and over longer paths. And I know that you said in a Jabber conversation on Monday that the problem was the content that you have the right to distribute is legally bound to U.S. Users. But for a platform that could be used for content that could be distributed internationally if you had the legal right to distribute that.
Yes, definitely. So Puffer's ABR algorithm, Fugu, can work on any kind of video systems. We have some differences compared with mostly widely used ABR systems, such as Dash.js. For instance, Puffer is sender-side ABR, and we encode video into 10 versions, more fine-grained, and we pre-calculate actually SN of each video, such that we can determine or optimize the QoE beforehand, before sending the video. But other than those differences, Fugu can work on any video systems, on any video service providers. And I agree with you that it will be a nice study if we can extend this work to more than one servers across continents, because it is indeed one limitation of us serving from one user to all users in the US. But I think the conclusion or the observation of noisy internet is somewhat generalizable, because we do see rebuffering events are so rare in practice that that's expected, right? Most of our internet users have high enough speed of networks to stream 1080p video, and that's why rare events like rebuffering has to be measured on tail users and has to be evaluated on a large amount of data. And actually, YouTube and Netflix confirmed our observation. So they didn't say that how much data they need to measure some ABR schemes reliably, but they did confirm that rebuffering is also very rare in their systems. So maybe they have a much larger user base. So maybe they only need 1 hour of like real world time, wall clock time, to achieve the same level of uncertainty we measured in our system over 2 years. Yeah, I wouldn't be surprised about that. But in general, rebuffering is rare for tail users. So I would say that the observation is kind of generalizable.
And you have this platform open for other researchers to try other things. So that's one of the things I wanted to be sure and call attention to here. Thank you very much, and I will get out of the queue.
Thanks.
Hi, Brennan, I think you're next.
I'd like to echo Spencer and everyone else. Congratulations for the really solid work. Very nice and well-written paper. I had actually a question about figure 6 of the paper. And
figure.
Yeah.
Yeah, I have it. Okay.
Yeah, so in figure 6, you show that there is a state update from the buffer video server to the MPC controller. So I was wondering, what is the information that is included in this state update?
Yes. I'm not sure. So yeah, I remember this question from the IETF opening meeting. And in this specific figure, actually, the MPC controller is responsible for calling transmission time predictor. So if you recall correctly, transmission time predictor is the neural network that takes a bunch of features and then predict the transmission time of the proposed chunk or the next chunk we want to send. Then based on this kind of information, the MPC controller can use value iteration, some kind of dynamic programming to plan ahead. So in this specific diagram, what we mean by state update is actually all the information needed by both MPC controller and the transmission time predictor, the neural network, to work. So that means the input of TTP, the sizes of past chunks, actual transmission times of past chunks, and the chunk to send, and also the TCP, so low-level TCP statistics, because Fugu or Puffer's APR algorithms run on the server side, so it's easy for Puffer to access the low-level TCP statistics, and also the SIM values, because in the objective function to optimize for model-based controller, we optimize some video quality minus rebuffering event minus the quality variation. So the quality is approximated by the SIM values we pre-computed, and then so SIMs are necessary input to the MPC controller itself.
Okay, so the transmission time predictor, does it output a probability distribution that is then sent to the MPC controller? How does that work?
Yeah, that's right. So it outputs actually a probabilistic distribution, but I think for like discussions simplicity, we can assume that for a second that it outputs just one point estimate, single value prediction for the transmission time of the chunk to send. So then the MPC controller can query this neural network for all the options, because, okay, let's still take another step back. Let's assume that the model-based controller doesn't run any net dynamic programming. All it does is brute force enumeration. So the model-based predictor wants to plan ahead, right? So 5 steps, that means it has 10 to the 5 number of options, because each step we have 10 versions of video as the option. Then if you think of model-based controller as some brute force enumeration, then we only need to evaluate how long it takes and how much QE we obtain by sending each of those 10 to the 5th options. And to calculate each of those options, we need to query, the model-based controller needs to query the neural network for all the unknown transmission times of those chunks. And then we come back, like we return to the original design of Fugu. Instead of brute force enumeration, we used dynamic programming to accelerate the computing to be more efficient. And then instead of point estimate as the output, we use probabilistic distribution, because sometimes the neural network is just not sure which value, which single value is the best prediction for the transmission time for the next chunk. A probabilistic distribution makes more sense, and we can easily incorporate the distribution into the dynamic programming of model-based controller.
Okay, cheers. Thank you very much.
Yeah, no problem. If that's still not clear, we can go to the offline. I'll be happy to show you.
Sure.
Yeah.
So I think we'll take one last question and then move on in the agenda. Thanks. Will?
Yeah. Hi. Sorry, I'll try to make mine quick. Hey, Francis. I work at Akamai, and we've been looking at Puffer for several years with interest, and nice to see somebody behind it. My question is about bias in your test data. Is the majority of the training for Fugu still coming from the test page that geeky people like ourselves go to test Puffer on? Is that it, or do you have alternate sources?
Oh, so what do you mean by test data?
The training, when you said you need a year's worth of data because buffering is so rare. What I'm seeing in the real world, looking at services like Peacock or Disney Plus, there's still a good amount of buffering happening. Probably 1% of sessions are buffer impacted in general right now. And I would think that's a much higher incidence of what you're seeing. And I'm wondering if that's because the people providing your input data are people who are selectively have better internet connectivity to begin with.
So if you look at the figure 9, the main results of our experiment, actually we also observe 0.2% rebuffering rate, and if on slow network paths, we also observe like 1.2, as much as 1.2%. So I think that kind of close to what you observe in practice in larger scale production, right? And in terms of the training data, maybe I was not clear. So the findings we had were obtained from years of data, right? The main experiments were performed on years of data, but the training itself only takes 2 weeks of data. So we, on each day, we take the past 2 weeks of data to train TTP, and then deploy this new version of TTP alongside, the other components of Fugu. Right? We have a new version of Fugu now, and then the new version of Fugu is only tested on the future data collected on users watching Fugu in the following day.
Okay, that clears up. Thank you very much.
Yeah, no problem. Yeah, I'll be happy to take more questions offline. Thanks, everyone.
Thank you very much.
Yeah, thanks Leslie and Kyle for having me here.
Great, thanks. Okay, so next up, we have Glendine and/or Sanjay going to tell us about the Streaming Video Alliance.
All right. So Glenn, I think I'll go first.
Should I switch to wired?
Leslie, can you hear me?
How does he sound?
Glenn? What was that?
Hang on, I'm going to switch to wired headphones.
Okay. Like we lost Leslie off of audio and video. So if you guys want to get started, Glenn is starting. Okay.
I didn't think everyone needed to watch me watch Glenn and Sanjay.
Yeah, I guess I should probably turn my own video off too.
I can't hear you. Sanjay, get started. I'll solve this tech problem while you're doing it.
All right, so why don't we get started here? Happy Friday, and good to see that we have IETF now extended into Friday, so maybe signs for good things to come. Anyway, my name is Sanjay Mishra, and I'm here to give a quick update on at least part of the slides here, and then I'm going to hand it over to Glenn. So next slide, please. All right, thank you. So for those not familiar with the SVA, the Streaming Video Alliance, and the Open Caching Working Group within the Streaming Video Alliance. So let me just do a quick recap. So Open Caching as a framework is a use case of content delivery network interconnection, i.e. the CDNI working group, in which the commercial content delivery network is the upstream CDN, and the ISP caching layer serves as the downstream CDN. So open caching, in general, the implementations rely largely on the CDNI RFCs, but the working group also does a lot of technical work, some of which does come into the IETF, and some of which just turns out into like best practices. Those best practices and the specifications essentially guide the open caching implementation. And to that point, the performance management specification that I'm sharing here, an update on, is essentially, this was published late last year. It specifies performance measurement for open caches. So given that the ISP hosted caches are primarily focused on delivering video content on behalf of either a content provider or a commercial CDN, this document specifies measuring performance of these edge cache nodes or the open caching nodes. And this document in particular essentially outlines key performance indicators of the open caching nodes, specifically both at the ingress and the egress points of the OCN. The measurement may include data such as HTTP response time, time to first byte, transaction throughput, HTTP error count, delivery bitrate, etc. The document, I've posted the link out to the document. Hopefully you should be able to get it. If not, you should be able to make a request and you should be able to then download the document. So I just wanted to kind of give you a quick view on some of the specifications and what they typically entail. So next slide, please. Okay, so a little bit of a switch in gear here. The slide here is to give a quick update on the intersection of work between the Open Caching Working Group and the CDNI. One of the active ongoing work involves extensions to the existing RFC 8007, which specifies control interface and trigger commands. The CI and trigger is a request for the downstream CDN to do some work relating to data associated with content requests originating from the upstream CDN. That is, the upstream CDN can use this mechanism to request that the downstream CDN, for example, pre-position metadata or content, or the upstream CDN can request to invalidate or purge metadata or content. So in the same spirit, the draft CDNI triggers extension adds several more capabilities and extensions, including use of regular expression to purge specific content, say within a specific directory path. The draft also adds several knobs for granular control for tasks like preposition and purge that can be localized based on, say, location policy. It adds a geo limit on content distribution, also by time policy to allow requests prepositioning take place between certain hours. And also lastly, the updates includes adding a generic mechanism for future extensions to trigger execution. The current document did not allow to do that. So given all these substantive extensibility proposed in this draft, the CDNI chairs actually raised a question to publish a new consolidated version that would potentially obsolete the current RFC 8007. So the task will involve essentially consolidating the work with the new work with the old work that's still relevant, and publishing a new RFC. So we're working with the chairs right now to update the milestones, and most likely we would be targeting to have the document go to the IESG by IETF110 in November. So that is what the plan is. And these are the two slides I think, Glenn, I am supposed to talk to and then hand it over to you. But before we do that, any questions on the previous two slides? All right, I don't hear anything, so let me pass on the baton to Glenn.
Yeah, hi there. So I swapped out my earpods.
Sanjay, I forgot to ask you guys, do you want to drive, or are you okay with me running the slides?
No, you can run the slides, Kyle.
Okay.
So next slide, please. So I'm going to walk you through a bunch of other stuff that the SVA's been engaged in. And in particular, I'm going to highlight areas like Sanjay has that we have overlap, because one of the purposes of this update from the SVA to the IETF MOPS group is to sort of help bridge what is sort of professional industry streaming, groupthink or activity over at the SVA into the broader work about networking and transport that the IETF does, and to highlight commonalities in places where perhaps the IETF can take some direction from what the priorities for professional streaming environments have. So one of the things that we've been working on over the SVA is live streaming. It's a big focus area for the streaming industry. Typically this is use cases for things like concerts, news, but very much around things like live sports. And so I wanted to highlight that back in, just recently last month, there was a new document published over in the SVA that talked about best practices for reducing latency in video streaming. And I'll point out that it talked about transports such as HTTP2 and Webrtc. It looked at QoE, and often when this topic comes up, people say, well, you say low latency, like what is low latency? These are the definitions that we use within that work. The low latency being within the 2 to 5 second range, ultra low being 1 to 2, and then near live being sub 1 second. So I'll take questions at the end, but so that's one thing. Next slide, please. The SVA, of course, is more than just sitting around writing best practices or writing specifications. It's also interested in helping bridge the gap between adopters, implementers, and a code base. And so one of the things that has been spun up is a new effort called SVA Labs. And I think this might be of common interest to a lot of MOPS participants, because we're going to be making code available that people can take and deploy. And the nice thing about this is in many cases code that's based upon IETF work that that SVA has taken, adopted into its environment to solve particular problems, and then releasing overall as open source. So right now, if you go there, this is a new effort we've started up, but we have a geo for IPv6, a JSON schema, and there's actually, we call it that, but inside there is also IPv4. We highlight IPv6 because geo-identification within the v6 space, of course, is a slightly more complicated process and not as well done to date around the world as IPv4 is. This is a schema that allows you to help update and provide information around the geo allocations of IPv6 and IPv4 address space. In process is coming capacity insight APIs and the request routing API that are coming out of the open caching group within the SVA. Next slide, please. And referencing back to the actual work that drove that, ultimately the Geo IPv6 JSON work is a document which the SVA originally published back in October 2019, and then later updated in March 2020. This is an actual, we took the work in a variety of RFCs that we referenced in the IETF, incorporated it into this work and allowed it for a means to be used for updating, as I said, the geolocation attribute association for IP blocks. This is getting a little into the weeds, but boy, is it important. So this one took a lot of work, I must say, and we're pretty proud of it. Next slide, please. So, you know, when we look at the larger landscape, and I know Will Law is going to be talking about low latency after this, a couple of real focus areas that we've been sort of talking about over the SVA, of course, is low latency streaming for live content. It's a big focus for us. And it's a big focus for the professional streaming industry in general. If you look at the landscape, you know, probably 3 or 4 years ago, if we were talking about what the big problems were, we'd probably be talking about, you know, how do we deliver at scale video that's been pre-recorded, such as movies or TV shows, and how to do that efficiently and how to do it without buffering, as we even heard from, you know, earlier talk. The new frontier, in a lot of ways, is how do we do that for live? The ability to stream, especially things like sports, is an interesting problem globally to the industry, and it's an interesting problem that consumers are really driving for, because you know, if you look at today, you know, historically, the latency or the lag of delivery of sports in a live thing can often lag considerably behind that which you either get through cable or through satellite when you're doing the streaming over the internet. We're trying to ultimately close that gap, and so that sports is just as good as cable or just as good as satellite broadcasts. Never be as good as being there live, but it'll be, you know, second best. Another area that comes up a lot is discussions around QUIC and HTTP3. Obviously, this has been a huge area of focus for the IETF. The interesting thing is, so far within the professional media space, it's an area that a lot of people are watching, a lot of people are discussing, but frankly, very few video services to date have announced that they've either adopted it or they have announced firm plans to adopt it in the future. I would say that while, you know, QUIC is a hot topic for the IETF, the adoption broadly is not quite there yet, but ultimately, you know, there's hope, right, for the IETF perspective that it will be adopted. We'll have to see what the future brings. Next slide, please. So finally, if you want to get in touch with us, there's 3 addresses I'll give you. One's mine over at NBC Comcast. There's Sanjay, who's at Verizon. And another point of contact is Jason Thibodeau from the Streaming Video Alliance. He's the executive director, and he's a good person. If you're interested in learning more, interested in getting involved and help the rest of us bridge that gap between what the IETF does and what's being done in professional media, Jason's a great person to go talk to if you want to get engaged with that work. And with that, I guess we'll open up for questions for Sanjay and I. I guess we answered all their questions, Sanjay.
Looks like we did.
We left them without
Don't
not even a single question about the peacock pillow behind me.
Is that
that's
like an award for years of service?
No. I got it at the gift shop in 30 Rock.
All right.
All right.
Well, don't go too far, because when we get to discussing milestones, we have an SVA item to address. So thank you very much for that update and putting us right back on schedule. Okay. Yes. So next up, low latency streaming. Will Law.
Will, do you want to drive, or do you want me to share the slides?
No, I'd like to drive. I have a lot of animation, so slides.
Will do then.
my PDF. And also I was going to try to do live demos because nothing cheers people up like watching a guy flail while his demos don't work. So I'll give you that small pleasure today, perhaps.
That sounds good.
Let me ask to share screen. I really want to share my screen. Yes. I have a very wide screen. You might need to adjust your web browser here. Come here and tell me if that's decent before I start talking.
So, Will, Glenn, if I can interrupt,
See,
one thing, if you turn off the video, it makes the screen display bigger for the rest of us.
Okay, I'm going to have to, I've lost the interface to turn off the video, so I'm going to stop sharing, come here, turn off my video, go back to sharing the screen. I put another request to share screen. I think you have to approve. Yes, yes, share, share. Is that better, Glenn?
It is.
Looks
Perfect.
better.
Okay, so thank you very much for the invite. I've been speaking on low latency a few times now. I recognize some people in the audience who've probably seen some of these slides will know this field very well, but hopefully this is a catch up on the low latency. And luckily, SVA and Glenn just spoke about some of the ranges and the names we're giving to low latency. So here's a chart. Mine pretty much aligns. We're looking at sub-second below 1 second, ultra low latency from 1 to 4 seconds. I think SVA was 1 to 3 or so, and then low latency 4 and above. What's interesting is we can overlay some of the applications that we might want to deploy across these latency ranges. And they're intentionally fuzzy at the ends because these definitions are not solid by any means, and nor do they need to be. One person's sport might need to be 3 seconds delayed, others can happily be at 10 seconds. Commercial broadcast, depending where you are in the world, typically sits about the 6-second mark, or 3 seconds if DVB-T2, up to 10 seconds satellite or cable in the US. But the real driver now for latency is social media. This is what is forcing much lower latency, people tweeting scores, goals in a game, or even chatting at that speed. So on the streaming side with segmented media, we've historically addressed latency by shortening our segments because we've always had a tight coupling between segment duration and overall latency. I think what I'm going to speak to you about today is really the new developments taking place in streaming down on the bottom right here, around chunked CMAF and the ability to start decoupling overall latency from segment duration. And this gives us end-to-end latencies in the 1 second on up. And that's what I'm going to speak about. Webrtc is another, obviously, the real standard choice if you want to be sub-second. So I'm not pitching at all segmented media to be sub-second. We have it working in the lab sub-second, but what I want to talk about is at-scale, international-based distribution for media. So luckily, 2020 was a rich year for us. We got 2 standards given to us to do low latency streaming with segmented media. We have low latency Dash, been worked on for a while, but officially released around March 2020. DBB came out with a very similar version as Dash IF did. And then Apple released LLHLS, as we're calling it, a low latency update to the HLS spec that was released in April 2020. Both of those solutions rely upon chunked encoding of the content. So I'm not talking anything about the transport or the delivery. This is simply how the content is prepared at the encoder. So imagine this is a 6-second video segment, and this is an ISO-based media segment. So we'd have an index up at the front, the move atom. We'll have a keyframe, the black box, and then the encoder would produce 6 seconds of data. And only at the end of that 6 seconds does it release it, upload it to the CDN, and the CDN distributes it to the client. So by the time you're uploading the very first byte of data here, it's already 6 seconds old. So to address latency, the encoder shifts to a different pattern. Instead of a single index, it makes a whole series of indices and a very short block of video data. So it makes an index. This block of video data, this MDAT here, might only hold 1 frame, 33 milliseconds of data. And at the end of it, the encoder starts an HTTP post up to the CDN and starts sending this 1 frame down. And then it makes another index and the next frame. The result is we gain 6 seconds of latency while doing it, or depending whatever our segment duration is. And this is fundamentally a concept used by both Dash and HLS to reduce the duration. So why does chunking reduce duration? Let's imagine we have an encoder making segments that are 4 seconds long. So if you look at AV Player and Apple, the default behavior, in fact, and that algorithm is copied by most players, is to have 3 fully formed segments in the buffer before to start playback. So if you do that, you're going to have 14 seconds of latency with this stream, because we're observing this encoder halfway through the production of the 5th segment. So we got 12 seconds plus 2 seconds, 14 seconds. Now you're a smart player developer. You say, I see an easy way to reduce the latency here. I'm only going to put 1 segment in my player buffer. So I'm going to trade buffer stability for latency, which is always a trade-off we have to make. And I can get, on that same stream, I can now reduce my latency to 6 seconds. But let's look at what if these segments were actually chunked. So we're imagining each 4-second segment is divided into 4 chunks. Now, only the first chunk holds a keyframe. So we have to start decoding from the first chunk that I'm coding as the darker green segment here. But other than that, we can play through. So now our starting option changes. I don't need to grab the full segment. I could start by grabbing the nearest keyframe that produced and the chunk after it, 5A and 5B. That would give me just 2 seconds of latency. And I can improve it even further by saying, you know what, when I might have to start decoding from this chunk, but I don't have to start rendering from that point. So I could decode seek forward into this data, and I could start playing at some point in the second chunk, which would give me less than 1 second of latency. I have another option as well, which is to make a well-timed request for the start of the next segment and its keyframe, which would be 6A. And that would give me a delay of 2 seconds, but then a low latency of 1 second. So the takeaway from this slide is that A, chunking can reduce latency, but B, the latency you see in a player is primarily a function of the starting algorithm that player chooses to deploy against the live stream. I could play this live stream with 1 second of latency. I could play it with 30 seconds of latency. I made a simple animation for a different talk. I'll repeat it here, just to show how these solutions are functioning in practice. We have a thirsty monkey and we have buckets. We want to get water to the monkey. So traditional streaming, the encoder would fill up the 6-second segment. Only when it's complete would it give it to the CDN. We would do the same, get a complete media segment. We would give it to the player. The player would retrieve the complete media segment before giving it to its source buffer, represented by the monkey, and we'd be able to drink and watch the video. So Dash solves this problem. We can model it as a set of leaky buckets. So we don't ever accrue the entire segment at any one part of the delivery stage. We're just allowing a continual flow of our media data down. Low latency HLS solves a different way. They just shift to very small buckets, which they empty very quickly. And that's a bit of a simplification. I'm going to show you a mode in which LLHLS can in fact function more like low latency Dash, and it offers a nice interop between the two, but we'll get to that later. So if you can read small text on your screen, here's just an example low latency Dash. It's got some differences to standard latency. We've got a latency target now. This is the service provider saying, hey, I'd like you, Mr. Player, to keep a 3-second latency on the stream if possible. These latency targets also have bounds. There's an upper bound, a lower bound, and a sort of target in the middle, because the reality is not all players can keep the same latency. And our mindset needs to be that the latency should adjust intelligently to match, especially the last mile and the player's characteristics. We've put in a UTC timing element here. That's also important. You can't have any slop in your timing if you're trying to keep 2 to 3 seconds of end-to-end latency. And also we have this notion of an availability time offset. This is telling the Dash player, hey, that segment that you normally would have waited for it to be complete at the end of its duration can actually be accessed early. So not too many changes to Dash. On HLS, here's the equivalent. HLS introduces the notion of parts. They came up with a new name, but if you're in the CMAF world, this is equivalent to a CMAF chunk or a CMAF fragment, depending on its size. So we have segments here that are 4 seconds long, but the parts are basically 1 second. And the last 3 segments worth of parts are described in the media playlist. And down here at the bottom, we have a very useful one, which is what's called a preload hint. This describes a part that is not yet finished production. So the player is allowed to ask for it early. And this is a simple way to solve a timing problem, because you can ask for it early, the origin will block your request and wait for that part to be complete, and then it will release it immediately. So you get it as soon as it's available. There are, in fact, multiple commercial and open source players available today that, by virtue of these two schemes I just described, will give you stable 2 to 3 seconds latency. There's the usual players. You can look at Bitmoving, you can look at Theo Player, you can look at Sharka Player, and you can look at Dash.js. And I'll be demoing Dash.js for you later today. An interesting side effect of some of the low latency work comes around synchronization. If you take an external time source, so that you have a trusted time source, and you introduce the notion of playback rate adjustment, which is the ability of a player dynamically to increase or decrease its distance behind the live point, in other words, its latency, by adjusting its playback rate, this allows it to hone in on a common latency target. If you tie those three things together, you get synchronization between players, and you get it in a very cheap manner. There's no need for the individual players to communicate with one another. I have a screenshot here of 3 independent players, a laptop, an iPad, and desktop, that are playing the same video within 2 frames of each other, within 66 milliseconds of each other, but entirely unaware of the other players. They're simply following this rule to play it with a very precise latency, and they're given the information to do that. So this is a nice consequence of the low latency work. I need to point out, though, it's not dependent on low latency. These players could all be 30 seconds behind live and equally synchronized. And I'm really surprised more services don't take advantage of this type of behavior. It's not tied to low latency, but because it's very useful as we move to low latency, I think it's something that could spread further out in terms of OTT synchronization. So let's just look at some commonalities very quickly. Both these formats require the chunked encoding. They support latencies from 2 seconds. And when I say support, you can use these to show sub-second latency in the lab if you want to. But I work for a large CDN. We care about getting media from Europe to the USA to millions of people. So I don't currently recommend going below the 2 second mark, and even that is reasonably aggressive. They're backwards compatible, they're cacheable, so we can get scale. They use HTTP for delivery, they support DRM, they support ad insertion. And when I say support, can you go and buy ad insertion today for low latency HLS? No, because the ad vendors are too slow in their decisioning systems to allow the insertion. But that's not a fault of the format itself. It's a format of the ad industry catching up with the new latency capabilities of media. It will catch up. There will be solutions like pre-decisioning the ad so it's available at the insert point. They support multiple codecs. They allow ABR playback, so we can switch bit rates. And as I mentioned, they leverage HTTP delivery. So a lot of commonalities. But there are some major differences. And I'm showing green and red here not to invoke good or bad, but simply to invoke yes or no. So green is yes, red is no. Dash uses something called chunked encoding transfer. So with HTTP 1.1, this is the transfer of what I'll call an aggregating asset, because under HTTP 2, it's not called chunk encoded transfer anymore. And there's confusion here with the chunk encoding of the media and chunk encoded transfer. But this is actually moving it across the network. And in fact, LLHLS can use this under certain modes. So there's a nuance to this bullet point here. LLHLS describes the internal segment structure. A dash doesn't currently. It will in a future update. We're using something called resync elements. HLS is quite verbose. You have a playlist refresh with every single chunk. We'll look at some of the consequences of that. HLS objects should be delivered at line speed. That helps with bitrate throughput estimation, but it also delays delivery a little. HLS supports TS segments. I will say that today, the vast majority of low latency work is being done with ISO-based segments, both for HLS and for Dash. I don't see anybody looking aggressively towards TS deployment. LLHLS requires HTTP 2 for the last mile. A Dash doesn't. You need a smart origin. with LLHLS because of this notion of blocking and also skipping and some other features that were added to HLS, whereas Dash can still work off a relatively simple HTTP server. And Apple, because it describes the internal segment structure, has a more deterministic startup. And Dash, you have to put some logic into your player to figure out where you are in this stream. But there's solutions to both of these. One of the biggest differences is in request rate between the two formats. So let's hypothesize we have a 6-second segment with 333 millisecond chunks. So we have 3 chunks per second and 18 chunks per segment. So my Dash client is basically going to make 1 request every 6 seconds, and it's going to get a slow, what looks like a slow response from the server, but it's actually the server giving out the data as fast as the encoder is producing it, which is a 6-second segment every 6 seconds. So this is what our requests would look like across the wire. And we don't need to reload our manifest to do this. LLHLS, on the other hand, has to make a playlist request for the audio chunk and then a physical request for the audio chunk every 33 milliseconds, and it must repeat that for the video chunk as well. Dash will give you 20 requests per minute to the CDN edge. The LLHLS on the same scale is looking more like this. I don't know what the refresh rate looks like on the screen share, but it's a lot higher. The end result, it's 720 requests per minute to the CDN edge. So in return for this frequent updating of the information that you're getting with LLHLS, you have quite a verbose request cadence. There are ways to reduce this, and I'm going to get into those. And one of them is using byte range addressing with LLHLS, which I think is very interesting, and I want to talk more about that. So we're a CDN, we care about cache footprint. The more we can cache at the edge, the better the performance for the client. So let's imagine a low latency stream that's got, we're looking at just the first 4 seconds of it. So if this is a low latency HLS stream, all the objects you see appearing on the left-hand side are objects that would appear in our cache in the first 4 seconds. There's quite a few of them, and I can overlay their sizes because if we're interested in cache footprint, it's this video segment, the monolithic video segment, the non-parts, that's actually the largest one in the cache. We have duplicate content, which is the video content broken up into parts, and then we have an audio, smaller because audio bitrate is smaller than video, the audio parts, and we have our text files around that. So this is sort of visual representation of the space this takes up in the cache. Notice the stuff on the left is what a standard latency HLS client would be loading, and the stuff on the right is what a low latency client would be loading. And they're different. So we have duplication of content and therefore cache inefficiency at our edge. Now, if we layer on Dash on top of this, Dash has additional objects. There's less objects that Dash is going to load, but it turns out the size of them is very similar to the standard latency client. You can think of the Dash client as just downloading the same stuff, but 1 segment ahead of the standard latency HLS client. So now we have a worse situation, though. We have 3 times the footprint. And what we really want from an efficiency point of view is a common cache footprint. How can we drive these 3 solutions from the same binary object that we might cache at the edge? The secret here lies in a mode of low latency HLS called byte range addressing. So on the left, I show a standard media playlist from low latency HLS. Every part here has a discrete URL. So I call this discrete part addressing. But there's an equivalent playlist in which every part is described as a byte range within the media segment of which is the constituent part. So these are equivalent in terms of the information they're describing. But the byte ranges are particularly interesting because if the player makes a request for the first part or the first range, and so here, this is for a segment at the beginning. So I know the start of the byte range, but I don't know where the part is necessarily going to end because it hasn't been produced yet. There's a bunch of text here, but basically the end result is the server needs to keep delivering the parts to you when you request the first part. So an open-ended response is going to burst each part as it becomes available. And this is a very nice consequence because that's exactly what we want. We want the parts to be sent to us as fast as possible when they're ready. So an animation of how this works together. I've got an encoder that's producing segments that are 4 seconds long. My HLS client is going to, my discrete one will request segment 1, part 1. The origin is going to block it until that part is ready. These are 1 second parts. Then it's going to burst it across the wire, which is this little burst. At the same time, the player is asking for the next part, and it bursts it. And we get a pattern that looks like that, pretty consistent, with this part is being delivered at line speed and not in code speed. The byte range addressing is somewhat different. The client asks for segment 1 as a single request. The origin will block exactly the same way. And at the precise time that it can release that part, it releases it into an aggregating response. So it releases the part, then there's a gap, no more data moves down that channel, and then it bursts the next part when that part's fully available. And the pattern looks like this. What's cool is these aggregating transfers are exactly what a dash client needs. So we can serve the HLS client and the dash client with the same object and the same data flow on the CDN. The startup request flow is pretty interesting. A client could make individual range requests, and in fact, I think it would make 7 of them to start up the stream. Or it can make an open range request, say, hey, from 0 to the end, and it would get all these objects. So that single request returns all the parts in sequence just as if they had been requested individually. And this is a nice feature, except we run into a problem. So if you're a CDN edge and a client makes a request for an object whose size you do not yet know, because this object is still being encoded, you have 2 options. You can wait until you've received the entire object and then give a 200 response code with a content length, in this case of 1000, because that's the content length. But you didn't know it when the client asked for it, but you're going to wait to give the response. This turns out to be the default behavior of a CDN, at least for Akamai today. But the behavior we want from a streaming perspective is slightly different. We want the edge server to give us the bytes it has and then be given open-ended 206 response until the last byte's delivered. But they're both valid use cases. And how does an edge server know which type of response the client wants? Does the client want a 200 or a 206? And it's so cool that this is an IETF meeting because there's an obscure RFC called 8673 to the rescue. And it basically says if you're a client and you want an aggregating response from an open-ended range request, you should send your last byte position using a magic number. And this number is a very big number. It happens to be 2 to the 53 minus 1, or same as max safe integer in a 64-bit system. The idea is you're saying, hey, this number is so big, the server sees this and says, I know what this client wants. This client wants an aggregating response. It doesn't actually want me to wait for the end of this file. Now, there's all sorts of arguments against not using magic numbers. I get that. However, this is a very practical solution we can deploy today. And in fact, Akamai has deployed this onto our edge network. We're using it for streaming. It's working very nicely. And Apple have also indicated they're happy to support this as well from their clients. So it's a very useful RFC that was written for an entirely different purpose, but turns out to solve this problem for low latency streaming. So the steady state case for an HLS client then is the client might start up asking for a request, but now basically every 4 seconds, it just makes one request for the object. It doesn't need to keep requesting the individual parts because they're all flowing down as a consequence of that open range request against the segment. So it's interesting that the HLS client only has to make one request per media segment duration. And also the curious fact you can win drinks at bars that you can play a byte range addressed HLS playlist without actually making any byte range requests. I can explain that to you in a bar sometime if you bet me. Quick chart here on request rate improvements. The details aren't too important, but depending on the ratio of part duration to segment duration, by using byte range addressing, you can reduce the overall request rate 37%, 40%. The asymptotic max would be 50%. And this is useful. If there are 1 million clients talking to a CDN, having 370,000 requests less per second is meaningful. A quick note on bandwidth estimation. So normally we have the bits delivered at line speed. In other words, they're limited by the throughput of the connection. we take the bits divided by the time, and we get an estimate of the throughput. And this has worked for traditional streaming. If we make the same calculation over this aggregating response, because we have this idle period in between, we're going to keep calculating that the throughput is equal to the bit rate of the video you're playing. And this makes throughput calculation very difficult because you'll never switch up or down. You'll simply keep playing the same stream. The solution is to, again, calculate your throughput over the incrementing or aggregating portion of this incoming data flow. That's a little more complex on the player. So players have to learn a new skill in how to estimate the throughput in the face of this continually aggregating response with intermediate idle periods. But it's possible, and players do it today. So in summary, byte range addressing with HLS offers better cache efficiency at the origin and CDN distribution tiers. It's a decreased request rate from the client. It's interop with standard HLS clients, low latency dash clients, and standard latency dash clients. It does require support of RFC 8673 at each of the components, origin, CDN, and client, to work effectively with mid-segment range requests. So these are not the standard requests. They're pretty much edge cases, but they're edge cases that need to be accounted for. Looks like I had another summary on low latency streaming. So both Dash and HLS offer solutions that I think are scalable in the 2 seconds and up range. Both rely on chunked encoding, and they're able to decouple your latency from your segment duration. They both rely on the transfer of aggregating objects. This complicates network delivery because the content length is not blown. So if you have a multi-tiered distribution system, which is essentially a CDN, it can have a hard time knowing the difference between a source that has stalled and no more data is coming, or a source that's simply waiting to send more data. So timeouts and retries become more complicated than they are where you know the content length, so you know when you either have or don't have the object. RFC 8673 is necessary, and byte range addressing mode is a cache efficient solution for combining the two protocols. You may not want to use it because you only care about one protocol. That's up to you. Then I wanted to try to do a live demo. For that, let me stop. Oh, wait, no, I can just get out of here. Okay, sorry, you're gonna see a bunch of screen rearrangement. So I'm gonna show you, I've got 2 web browsers here. And on the left, playing Dash, we'll just start here. Let me just get it up and running. I'm going to mute the audio. So this is a stream whose origin is in London, in the UK, and I'm in San Francisco. So we're playing a good distance. We're using Akamai CDN to take the content from London to me here in San Francisco. I've set this player up with a target latency of 2.5 seconds. So you should see here in the chart, the player is honing in on the 2.5 second latency mark. The red line is showing my player buffer. My buffer can never exceed my latency. Now here on the right, let me just reload this page, is a low latency HLS player coming from the same origin. So this is indicating that use case I spoke to you earlier of, where we have the same objects coming from the origin and being cached at the CDN edge. The low latency HLS, the chart here is a little different because I got a number of different objects. These segments being used in both these solutions are 8 seconds in duration. So the fact that I'm able to, let me just lower my latency here to 2.5 seconds. The fact that I'm able to achieve 2.5 seconds end-to-end speaks to the decoupling we're able to achieve between the segment duration and the overall latency. My segments here showing on time are still being downloaded in 8 seconds. That's because they're being downloaded at the speed they're being encoded at, which is 1 second per second. Notice all these little orange requests. These are all the media updates. My chunks now are 500 milliseconds. So I've got 16 playlists that I update in between every media segment request. But it's working internationally, as you can see it here. And I have pretty close sync between these two streams. They're playing independently of one another, and they're playing pretty stably across the CDN. And I can go into more depth. I don't think I have time. If we want to look at the network panel, because it's a technical audience, you can start to see these media segments being produced. Notice each of them, as I mentioned, is 8 seconds long. So we have a slow download. The total time it's sent is just under 8 seconds. We'll burst a little bit because of encoding and transfer time, but essentially the segments will all take 8 seconds to come across. If we look at the network flow on the low latency HLS side, I have a lot more requests going on. These are all playlist requests. If I filter for MP4, you'll notice we get the exact same behavior here. We're downloading an 8-second object in just under 8 seconds, and it's coming through. The difference between the two formats essentially is the playlist updates. Okay, and with that, I will stop sharing. Okay, and I'm happy to take questions.
That was really great. Thanks a lot, Will. We should definitely take questions. We are at the risk of running over a little bit, but I suspect that people will gladly trade off time in the discussion of milestones for this. So go ahead, Glenn, you were first in queue.
Will, you are the bravest of all presenters I've seen this week at the IETF. My hat is off to you, sir.
I'm just naive, that's all. Sorry, what's your question, Glenn? I spoke over you.
No, I said I don't have a question, but I had to share that comment. My hat is off to you, sir.
You're welcome.
Jake.
Yeah, that was amazing, Will. Thanks. So my question is, do you think there are best practices that should be carved in stone and published today? And if so, what would they include?
What's the scope for that question? Around segmented media low latency streaming?
Yes, basically. Well, actually, anything you think is relevant in this space, I would happily hear about, honestly. But yeah, specifically that.
So best practices should never be carved in stone. They should be written in disappearing ink so that when they change, you can ignore all the old ones and just move to the new ones. I mean, that's a real danger literally in carving anything. We do have standards, which is great. We have a clear LLHLS spec. We have a dash spec. What's missing is the application of these. In other words, what's consistent caching rules for HLS? How should CDNs cache the various components and for what duration? There's some allusion to this in the spec, but the spec talks more about the precise formatting of the content and less about the mechanics of its delivery. So that's where groups like Dash Industry Forum has guidelines for how to do low latency dash. And I think SVA, from what Glenn alluded to, is also looking at practical recommendations for these formats. Those I think are super useful. They're useful because you can get consistency between CDNs and in a multi-CDN environment. And you also get consistent behavior. Players react in the same way. A big gap I'm seeing today in the industry is still player behavior in the face of problems. So if you have a missing segment, one player will keep retrying that segment 3 times, then try another bitrate, and then try an alternate URL. Another player will retry it 52 times and then roll over and die. There's really no consistency in failover operation in players. And therefore, service operators don't have a consistent quality of service when they have a problem. Each player goes and does something slightly different. So there's an issue. So I think industry groups taking specs and then conditioning them with guidelines that are updated frequently, and I'm talking at least annually, make a lot of sense in order to get robustness in these formats. And there's new advances, there's additions coming out every year in features we can do. So I'm absolutely in support of those type of actions.
Great, thank you.
Great. Thanks. Any other questions from people? Not hearing any, then I think we'll say thanks for now, Will.
Oh, sorry, I pressed the wrong button, trying to kill my video. Thank you very much for the invitation.
Yeah. Great. All right. Now switching gears just a little bit. We'll go to some of our own working group work and discuss the state of the OpsCons document, which I think Spencer is going to take us through, please.
And Spencer, do you want me to share the slides, or do you
yes,
want
please. Yes, please. For extra credit, Spectrum is having a outage in our service area, so I'm actually hotspotting my cell phone.
Low
Yeah.
latency,
All right,
no
give me
doubt.
1 second. Why is
Slowly,
this not
yes,
working?
exactly.
Okay. Is it actually sharing?
I see the agenda.
You do?
It's
Okay.
I'm seeing you transmitting something.
Yeah,
There
all
you
I'm
go.
seeing.
Now we
Oh,
have it.
that's what it is. Oh, I had it in gallery mode. I'm like, why isn't it sharing? Yeah. Okay.
Okay, cool.
And page fit, and that's interesting. There we go. All right, that look all right?
Are other people seeing this?
Looks good.
All right.
I
Take it
am
away.
not, but I have my slides up so on my laptop. So let me just start from there if that's okay.
Yeah, make sure you don't have it in gallery mode. I had to switch back to presentation view in MeetEcho to see the slides, because gallery view doesn't put the slides into one of the blocks.
Okay. No, I'm saying I have my slides up that I can see. Okay, now I'm seeing yours. Excellent. Thank you.
Okay.
So let's go ahead and start. So we're talking about status report and updates. Next slide, please. So, and I'm actually looking at these on my screen, so I don't have to wait for MeetEcho to paint. On the next slide is the outline. Talked a little bit about the status of this milestone and beg for forgiveness. Well, I'm sure we can talk more about that at the end of the session. We have some issues in GitHub that have proposed text, and we should move forward to merge these in the next update. Then we have some open issues, and I want to stop for comments and questions. And then I want to talk about solicitation update. Next slide, please. Okay, so we're behind on this. COVID-19 was a reasonable excuse, but that's so 2020. This is the working group's only adopted draft, so we should probably work on it. We talked about this at the interim, actually, moving the milestone to July, but that probably really needs to be for real. We actually have some cleanup to do, but maybe not as much work as we thought. Since the interim just before 109, we obviously need to spend a lot more time in GitHub. And I note that moving the milestone to November also gets us ISG review, recharter, closed working group. So for a couple of reasons, I really like July. I should also mention, as we do the next slide, I should also mention that this IETF is pretty early in the year compared to other spring IETF or first IETFs, and the summer one, second IETF, is pretty late. So this is an opportunity for, it's a nice opportunity for another interim, which seemed to work well for us. Are you guys on slide 4? We do have issues with active text in PRs. The one on low latency versus others, we actually do have a PR for that. That we've had lots of discussion on in GitHub, more discussion than we've had on any other issue or PR. It just needs to be applied and updated and applied. let me skip down to number 31. We have a section from Matt Stock on adding a section on ads, and I thought we had an action for somebody to talk to Matt and see if they could establish contact with him. According to the minutes from our interim meeting, did that happen? Oh, Mike, please.
Yeah, I spoke to Matt, and he's okay with whatever we want to do. So I can make edits if needed, or we can adopt what's there, or he's okay with us taking what he has there and adapting it as needed.
Okay, excellent. So we are good on that one, which is where. So it's probably worth looking at the PR for issue 24. If you could click on that for us. This was to we did a wildly unpredictable section after the COVID-19 unpleasantness last spring, and so while we our last conversation about this was that the IEB was having a workshop on impact of COVID-19 on networks, and that actually happened, and so I've got new text on this. Have you clicked on that yet, Kyle?
Spencer, sorry, I forgot I wasn't actually, I forgot that you asked me to click on the issues. Which one do you want me to click on? 24?
The one for 24, yeah, so it's 33 is the PR.
Okay, my apologies.
And you're fine, you're fine. Yeah, there should be a linked PR on this. I'm actually trying to do a better job on that too. So if you could just display the PR, and that'll basically show what I was proposing.
Let's see. There we go.
Yeah. So can you look at all the changes? I've got 2 commits.
Do you want me to?
Okay,
Do you
cool.
want the commits or do you want files changed? The files changed shows you the cumulative.
That would be fine.
Okay, that's what we're on now.
Okay, excellent, fabulous. So basically, we had 3. So basically, Sanjay did a presentation on this, and I was referring to the references that he was using in his presentation also. I just deleted those and then added the one for the IEB workshop draft report. So if you just scan down to subsequently at the bottom of the slide, or at the bottom of the page, that would show what, basically I'm doing a summary here of things that seemed important to me. If people would like to check my math on whether there are other things that they think would be important to say from the IEB workshop draft report, the draft report is in there as a reference also. I should stop for questions or comments. And give people a second to come to click on and raise hand. My default on this would be to go ahead and merge this PR and submit an updated version of the draft that includes it. If nobody has thoughts here, or I could wait a week and see if anybody has thoughts on the mailing list. Hi, Lynn.
Hey, Spencer. So question here then. How does this intersect with the difference between sort of the use during COVID of a lot of streaming content and versus the video conference, upstream, downstream, sort of going on at the same time. Do we need to break that out as a distinct piece of it, or do you think that this covers it already?
So I think the workshop report definitely. So and I'll just say this and let other people tell me I'm wrong. It seems like to me that a lot of the impact was having a lot more traffic off peak. So for like ISP networks and stuff like that. So, and that was theoretically a lot of people doing video conferencing and VPNs from home during the day, where they might have been doing that at work or someplace else before. But they like I said, they did call out the usage pattern of applications as well. So I mean, they had a good workshop report. I was just trying to minimize the amount of information that I was putting in here, since the workshop report is a reference.
Okay, that seems legit. It would be fun to be able to see how many people were watching, movies off of Netflix while they were also video conferencing for work or school.
The report mentions that also, and I think I even. Yeah, and entertainment applications as people watch videos or play games. I could probably reasonably say at the same time when they were theoretically working. But yes, that was exactly the feedback from the IAB workshop. Thank you. Anyone else? Cool. I will look at the minutes after which conveniently Jake is taking, and we can do this back with when we are doing an update. So next, if I could get the next slide, please. So especially on the first page, I would recommend people volunteering. I really am looking for people to start a PR, just using the discussion that it's already happened on the issue. There are a couple of these that are on the next page that we really do need somebody to work on the issue itself. But the refinements to TCP idle time discussion. This is and if the chairs think it would be helpful to look at the issue and let people see the discussion that happened there, that would be fine too. Just to encourage people to volunteer to work on the PRs. And
so Spencer, while reviewing your slides, I went and I found myself a couple of these points. I forget precisely which ones, but I am volunteering to take on some of this. But
oh, fabulous, fabulous! So can I just
the specifics are there on GitHub as far as what I've done now. But yes, I encourage others as well to take a look into more of this. Yeah.
Cool. Could I ask the people that come to the mic if you could turn off your video? That would help a lot, because Jake was breaking up for me, but I know where to find him after the meeting. So the end-to-end encryption one, which is issue number 4. Conveniently, these are starting at the bottom. Is it easier if we start at the top and go down, or what's easier for you, Kyle? If people are looking at the slides, they're in ascending order.
Yeah, and I think I have a question about how much of this we're going to resolve here versus how much it's important here to raise awareness of these issues and get them resolved. get them resolved afterwards. I don't think that in 20 minutes we're going to get all of these reviewed and resolved.
Right, and so my theory was that if we had text on it, we could resolve those issues here and just apply things. But these are the issues that we don't have text on yet. We just have a lot of discussion, which a lot of it includes suggested text in the issues. Does that make sense?
Largely, although I'm a little bit concerned that apart from the fact that I'm concerned we've lost Kyle, I don't know. I think I would take suggestions from other people who will likely be offering text as how you'd like to process your way through this as we wait for Kyle to hopefully come back online, or else I'm gonna have to figure out how to share slides, which could be exciting.
It'll be more exciting than me sharing slides. I'm doing pretty well with audio in and out of about 30 kilobits. Anything beyond that, I'm going to have issues with. Oh, it looks like Kyle's coming back in.
Hope so. Here we go.
Okay, I'm back and my audio should be working now. My apologies.
Yeah, it is.
Sounds like it.
No, you're good.
All right. So
I
where
did ask.
do I need to share?
Yeah, so we're where we are where we were when you left us. And I asked people if they would like to express how they would like to process through this. I've not heard anything on audio, although I observed Mike English comments in the chat about that only one is still unassigned. Mike, would you like to come to the mic?
Hi, Mike.
Yes. So sorry, I missed the second page in the slide deck there. So there are a couple more issues. I was just kind of trying to sift through because I know Jake had said he had self-assigned a number of those. So it looks like 14, 22, 6, and 32. So
these are the ones. These are at least what? Yeah, 14 and 26. We don't have any a meaningful amount of text in the issue, so those are actually somebody to work on.
okay, so it looks like 32 is still unassigned.
And that could be cool.
Adaptive bitrate at low latency.
Yeah, I'm currently displaying all of the issues that are assigned to nobody.
Oh, good. I knew I wanted to ask you to do this. Thank you.
Okay, so I think 32 was opened by Luke, and I see him on the call. I don't know if he wants to comment on that.
Yeah, sure. I can.
Hi, Luke.
Hello, I'm Luke from Twitch, and this is very similar to. Will had a slide on this actually, where when you're doing chunk transfer with like LL dash or any sort of chunk segment, bitrate is very hard to estimate. So it's worth mentioning because players don't have a good solution for it right now. It's all over the place.
If you could respond to that, Jake. Luke was breaking up for me because he was also doing video. Sorry.
Yeah. So I guess it seems to me like the right action here is to reference the right references. I'm thinking actually some of Will's slides might be might be a good source. There
Ooh,
also
score.
might be. Sorry.
I said, ooh, score.
Right. I think we'll also. I was actually, kind of thinking about this when I asked my question of Will about like where would you look at the right places to do sort of best practices and what should be written down. I think his answer was very informative and helpful, although complicated. So I think the right thing to do here is to try to capture some of this through references to good sources, rather than trying to make with maybe a little bit of text about like, well, this is going to be complicated, so you should do research, because I really got to think that making concrete claims in this doc is going to be out of scope, right?
Yeah, it's certainly out of date quickly.
Yeah, exactly. Like there's no keeping up with this in, whatever we write down today is obsolete tomorrow, right? Yeah.
Yeah. So do we kind of know what to do with this one?
Sure, I will take that one too, unless I don't know, like, Ollie, do you want to do any work here on some of these, or?
Well, he does have one assigned too. So
Yeah, okay. I don't mind trying to find the good references and put in a paragraph about this. I'm not sure it's possible to do a good job here, but I can take that and try and do what I can. You can assign it to me, sure.
okay, and we also needed help with the number 14, the standard metrics one. Unless you've no, that would not be assigned at this point.
I did actually self-assign that. I kind of remembered that Aaron maybe at one of the prior meetings commenting that we probably have some material somewhere, and if I just go look it up and find out where, if somebody has recommendations to send me on that, I would find that helpful, but I can go annoy people as best I can. Again, I'm not sure it's going to be good, but I will try to put a straw man together at least.
Yeah, I honestly, I will say I'm kind of expecting that we're going to go through some stuff where we say, we need some more stuff in, we need some more stuff out. But just getting an update of the document that the working group can work on would be great.
Sure.
So what else are we lacking? You got 14? Is that right?
I believe so.
Okay. And if somebody does not want to, if nobody else picks number 4, I think I said I could do that one if nobody else signs up for that. But again, if I take a shot at the text and you end up sending comments on it, you might as well have written the text anyway. So
I actually think it's way easier to comment on something somebody else wrote than to write the first draft. So if you want to take a crack at the first draft and then like trade afterwards, that'd be great.
Okay, perfect.
Honestly, on any of these, really.
Well, I mean, I've tried to stick to stuff I understand. So, yeah,
that's part of my problem.
Yeah, but the end, but ideally the working group covers the things that we don't understand. So, and normalizing the white spaces, we just wait for a while on that.
That's just a text update sort of thing.
Yeah. I mean, like a new line deleting exercise or inserting either one.
We can do won't fix on that, or somebody can just do it, I guess. I don't mind trying to do that either, I guess, but I put it low priority. Okay.
Cool. So are there any left that we need help with that we don't have help yet?
Did we have any further updates on the ad stuff? Like, I'm not sure that what's there. If I remember right, in the comments of this, it was
Yeah,
question.
I understood. Mike, right, to say that he could do updates on that if needed.
So
Mike,
I appreciate. I'm
sorry.
Yeah. Sorry.
I guess I wanted to ask for confirmation from Mike on that, because I understood him to say more like Matt is fine with whatever you think is best.
I was going with and I can edit stuff.
Okay. Okay, great. So you're taking that one.
No, I'm saying Mike said that.
Okay.
I thought,
Leslie, you were saying,
Mike.
I'm sorry to interrupt you.
Mike, go ahead, clarify, and then
sorry.
and then we're gonna talk. Yeah.
Yep. Yeah. So to clarify, Matt said, "Do whatever you think is best," and I offered to help with that. So let me know what you think we should do with that PR. I'm happy to open another PR with largely the same content and whatever changes we want to make. Yeah. So
Cool.
yeah.
Thank you, Mike. That's great. I think that may get us to my last slide, which was just asking what else do we need to include in this document? It sounds like we're bringing in stuff from SGA already. We were talking to Mile High Video also. Is that right?
You mean SVA?
Yeah.
Yes. Of course I do. Yes. I'm sorry.
And Glenn, were you going to speak to Mile High Video?
I was not.
Or is that an Ali thing?
I think Ali, if he's still on, is more directly connected than I.
Cool.
I'm not seeing him unmute. And we do need to move on. So I think that we probably need to, I think we probably need to keep the, Go ahead.
Well, Leslie, one thing I'll say about the Mile High Video. Mile High Video is a conference versus a group that itself produces documents.
Yeah.
Like the Streaming Video Alliance. So, I mean, we can talk to them, but I'm not sure that there's a Mile High Video entity to give feedback directly, if you see what I mean.
Right.
Yeah, I thought there's maybe more soliciting wider feedback from individuals kind of thing.
Yeah, so I don't want to spend a lot of time on that because I think it was an Ali thing, and Ali is only notionally here. So if he can't join in and tell us what it was that he thought it was important here, let's just take that one off the list. And note that SVA outreaches is underway, and we can revisit any open issues about solicitations as we go along on the list. That
Cool.
sound reasonable?
That sounds fabulous, and I can finish just by suggesting that we do a virtual interim sometime between now and IETF111 because forcing functions do force.
Yeah, I appreciate your volunteering to organize it.
Thank you.
Moving right along.
All
Thanks,
yours,
Spencer. Yep, thanks. Next on our list is the update on the, hang on, I have it right here. Media operations use case for an augmented reality application on edge computing infrastructure. We had scheduled 20 minutes for that and then 15 minutes for milestones, and apparently I'm completely incapable of math. So I made an agenda that's longer than our session. Rhian, please do step up and take us through your work. If there's any way you can do it more quickly than the time allowed, I would certainly appreciate it.
Sure. Can everyone hear me? Can everyone hear me? Hello?
We can hear you. Thanks.
Perfect. Hi, everyone. My name is Ian, and I
Present,
will.
or do you want me to run the slides?
Can you please drive the slides for me?
Okay, we'll do. If I can find them, here they are. Sharing. How do I do this? Can you see that or no?
Yes, I can see.
Yeah,
that.
sorry, we're gonna have to. I can't put it into presentation mode. This'll have to.
Let's go with this then.
Okay.
So I'm going to present an update to our draft, which has been co-authored with Akbar Rahman. Next slide, please. We have added 2 new subsections to the draft. We have also made editorial changes as appropriate throughout the draft. I will talk about these changes in the next few slides. Next slide, please. We got very helpful comments, suggestions, and questions at the last working group meeting and have incorporated them as updates to the draft. The updates are along these 2 dimensions. Firstly, we clarify in the draft that it is the heat and battery drainage problems in AR devices that require offloading of computationally intensive tasks to the edge. Secondly, we list the kind of computationally intensive tasks that are required and give references for further details. So let us look at the first of these updates. Next slide, please. The reason why computationally intensive tasks need to be offloaded to edge devices is that excessive heat is generated by the chipsets that are involved in the computation. Additionally, the battery on such devices discharges quickly when running such applications. Both of these effects, heat generation and battery drainage, are a consequence of AR applications performing tasks such as real-time processing and generation of high-quality video content. So let's first look at the real-time processing of scenes and what that entails. Next slide, please. The AR application that runs on the mobile device needs to first track the pose, which includes coordinates and orientation of the user's head, eyes, and also the pose of objects that are in view. This requires tracking natural features and developing an annotated point cloud-based model that is then stored in a database. To ensure that this database can be scaled up, techniques such as combining a client-side simultaneous tracking and mapping and a server-side localization are often used. Once the natural features are tracked, virtual objects are geometrically aligned with those features. This is followed by resolving occlusion that can occur between virtual and real objects. The next step for the AR application is to apply photometric registration. This requires aligning the brightness and color between the virtual and real objects. Additionally, algorithms that calculate global illumination of both the virtual and real objects are executed. Various algorithms to deal with artifacts generated by lens distortion, blur, noise, etc. are also required. Next slide, please. The second set of computationally intensive tasks involves the generation of high-quality video that has the properties described in the previous step, and then overlay the video on the AR device's display, a step called situated visualization. This entails dealing with registration errors that may arise, ensuring that there is no visual interference, and finally maintaining temporal coherence by adapting to the movement of users' eyes and head. Next slide, please. So questions, comments, and suggestions are invited from the working group to improve the draft. And does the working group think that the draft is ready for adoption?
Start with the questions and comments. Cullen?
Just one. I mean, like the draft. I thought lots of stuff you had was really good. One thing that I think that would be well worth talking about is the latency budget for this computation. So particularly from the time from a head rotation to the time the video needs to be updated. I mean, I see lots of different numbers, but I think when that starts becoming below about 150 hertz, people start to feel seasick. You can get different numbers from different researchers or whatever, but I think that aspect of it would be really useful information to have in here, because it really does constrain how close to the edge this offboard rendering needs to happen.
Sure. Yep, that makes sense. Questions?
All right. So thank you for the update. And I guess at this point, the key question is, what do people think about adopting this as a MOPS working group document? I would like to hear some commentary. Spencer.
Started ringing when as I raised my hand. I think that this document was in fine shape for the working group to work on, so I would support adoption. Thank you.
Okay, thank you. Any other comments for or against? Okay, see a comment in the chat. So I think I would like to get a bit of a sense of a bit more concrete a sense, and I think we're going to have to figure out how to run a poll. The show of hands tool. There we go. This is not going to be definitive. Yeah, this is not going to be definitive, but I want to get a sense of where the people who are here are at. Let's see. And I think if I have succeeded in doing this, and there's very little probability of that, we now have a poll, a hand-raising opportunity for should we adopt the AR use case document as a working group item. And people are already carrying it out. Thank you very much. So if you are in favor of it, please raise your hand. And I will give it about another 10 seconds. Obviously, if you're not in favor of it, please do not raise your hand. I will, after we have done this, ask if there are further comments. Okay, so 9 of the 28 participants have said that we should adopt it. Do we have any objections to taking that supposed approach to the mailing list for confirmation, or are there other things we should discuss at this point before we do that? Okay, and I now have 10 raised hands out of 28. I'm not hearing any objections to that, so I think that my takeaway from that is that there is support in this room for adopting it. We will take it to the mailing list for confirmation, and take it from there. Is that how you read it, Kyle?
Ask. So Jake asked a question in the chat. Do we traditionally ask for how many have read it? Also, I've heard in other working groups the question asked, who is going to help work on this?
Mm-hmm.
As a maybe a better proxy for interest than simply asking who thinks it belongs in the working group.
That's a good question.
But I don't know that we need to actually run a poll here. But I would be interested to hear from people who have who find this interesting enough that they'd be willing to work on it, willing to help out.
Yeah, so I've asked a slightly different question, and I've asked about the willing to review and contribute text, because I think it's a very fair point. So if you are willing to review and/or contribute text, please raise a hand. If you are not, please do not. And the good news is I see more hands going up than there are authors of the document. Current document, I'm seeing somebody not raising their hand. Okay. Answers are still coming in.
That looks good. It looks like there's interest. So
yes. Although I would like to know if the person who did not raise their hand is willing to say, there is no list of names, sadly. If the not raising a hand is a matter of don't have time or outside of area of interest, that's fine. If it's an objection, please unmic and share your objection.
So it's basically me not raising my hand, lack of time and lack of expertise.
Sure.
No problem.
Okay. Good. All right. So great. So I had 10 raised hands for the should we adopt it, and 9 raised hands for willing to review and contribute text, with Eric's non-raised hand. So I think that's consistent. So thank you very much, Renan, for presenting, and we will take to the list formally take to the list the question of if we are adopting this as a working group item phrased in the assumption of yes. Cool.
Cheers. Thank you very much for giving me the time.
Great. Thank you. Which takes us to the last item on our agenda, which is a discussion of our milestones. And Kyle, I think you have that.
Just pulling it up.
Great.
I believe that's it. There we go.
Sanjay, you unmuted. What were you wanting to share? Didn't mean to cut you off. Oh, you remuted.
That was just opening up the mic just in case I needed to speak something, that's all.
Great, thanks. Cool. All right, so I think the next slide is the set of milestones. Yeah, so next slide, please. Great. So this is the current charter milestones, some of which are even done, yay. Some of which have become overrun by events. And we've discussed this a little bit at the last IETF meeting and notionally on the list. So next slide, please. This is what we proposed on the mailing list as an update to our working group milestones. And I think that we agreed that the AR document we've just discussed could be the initial working group document on network operational considerations. So I would, as a friendly amendment to this text, suggest that we align it better with the document title. I've highlighted in yellow the draft document of the SVA reliance on IETF protocols because that one, we had a presentation. So Glenn and/or Sanjay, would you like to comment on whether you think there's a document here or whether we should be pushing it off or what?
So we think there's a document here. The hope is to use some of the presentation we did today as a trigger to help fold things into that mapping between the SVA's input to the MOPS group and vice versa. That ultimately would produce a document. It's just, I'll tell you, sort of the forcing function that's is these discussions, which helps. It's a very tough priority to make given all the other things that are going on, but we'll get there.
Okay, so then I would suggest, it sounds like we should sort of push the SVA document milestones off by sort of one meeting cadence. So make that a July milestone, and also the SMPTE document, push that we were going to revisit whether that one still made sense in July. I'm thinking maybe we should be revisiting that in November, if that makes sense to
That seems
people.
to make sense to me.
Okay, not hearing any other comments, although certainly open to other comments. I appreciate that we're starting to get milestones that reach beyond our committed lifespan, namely that in November of this year, the ISG is slated to review whether or not we're rechartering or closing the MOPS working group. I'm not entirely sure where that's going to sit, given that it's been a crazy 3/4 of the MOPS working group lifetime will have been insane. Eric, perhaps you'd like to comment.
Yeah, I mean, I would not worry too much about this November deadline. You remember the discussion for chartering this working group? So it was part of the deal. While I see, and Warren, you are there as well, where I see there is activity in the working group, their draft, their presentation, I would not worry at all to continue the working group, right? I think we made, as a working group, made this a success, so I would not worry too much.
Okay, thanks. Warren?
Yeah, I mean, I largely agree with that. You know, it looks like we're doing stuff, things are happening, there is discussion, there's been no real drama or, you know, people punching each other. So I think that it makes sense for it to carry on. There is always the risk that, you know, the ISG does something crazy because somebody decides that they don't understand the sort of discussion type thing. But I think the chances of that are really small. So
Okay.
I think it's all good.
All right. Thank you for that. So I will take that as at least firm enough that I won't worry too much about milestones that appear after that point in the charter lifetime, and we'll just take it as it comes. So what I propose is that we then, I'll share this with the list one last time, give it like a 2-week discussion period, and then actually update the milestones. And it will appear as shown here, with the exception that the SVA and SMPTE documents will be one meeting cycle later. And having said that, I know that Spencer alluded to the fact that the July timeframe for last calling the document, the ops cons is kind of looming, but I think it's worth keeping in that time frame, even if the document hasn't progressed quite as much as aspired. Spencer.
Yeah, the last interim we had was mostly a drafting session on that document, and it was very helpful. So, like I say, forcing functions force.
Okay, so at the interim that you organize to move that document forward will be before July, and we'll last call it in the July time frame. Cool. Any other comments or questions? Any other business? Did we just bring the working group meeting to close on time? Oops.
It's looking like it. Oh.
Go ahead, Sanjay.
I was just saying you're 2 minutes early, so this is good. Right on time, almost.
All right. Well, with that, I would like to thank Jake for his note-taking efforts, and thank everybody for coming out to participate and engage in the meeting. Thanks to all our people who are willing to be agenda victims. Great. Thank you, everyone.
All right. Thanks, everyone.
Thank you.